7.4 exercise question number 5, integral of 3x upon 1 plus 2x raised to 4. So you need to use the substitution. More or less x is a derivative of x squared. If you differentiate x squared, you will get 2x, but 2 can be set. So what I'll do here, I'll just put x square equals to t, substitution. So what's the differentiation? 2x dx equals to dt. I wrote directly now. Now you have x dx here. This constant will come outside, remember. So what is x dx here? 2 will go that side, so half dt. So the integral equals to 3 outside being constant. This x dx becomes half dt, so outside half dt, 1 upon 1 plus, you have taken x square equals to t, so x raised to 4 will be 2t square. X raised to 4 is x square the whole square, Okay, so now this is standard form. You can rewrite as 1 square plus this is root t the whole square dt. So this is which form? It is x square plus a square. This is a linear function, remember. So this is nothing but here tan inverse t. T means root 2t upon the coefficient of x, which is root t plus c. What you did here, this is like x, so you have used this formula, x square plus 1. What is the integral of this? It is tan inverse x. So this is like t here, or x square plus 1 square, which is 1, which is tan inverse x upon the coefficient of t, which is root t. So 3 by 2 here, tan inverse, you can write 2 root 2, I'll keep root 2 over here only, root 2 into t. What is t? That is x square plus c. Okay. Now question number 6, which is like first question only. So in the 6th question, you have x square upon 1 minus x raised to 6 dx. Now at this place, x square is derivative of x cube with constant, of course. So put x cube equals to t here. Right? So you will be having 3x squared dx equals to dt. And now 1 by 3 over here, and this x square becomes x square dx become dt. So you can integrate it further. Okay. Next question. Question number here 7. So you have x minus 1 upon root of x square minus 1 dx. Now at this place, if you notice here, this is quadratic expression, this is linear. What's the derivative of this one? 2x. So I'll split into two integrals, so you can do very easily. X upon root of x square minus 1 minus 1 upon root of x square minus 1 dx. Split into two integrals. This upon this minus this upon this. Now this is a standard formula, if you remember. 1 upon root of x square minus a square. 1 you can write as 1 square. So this can be integrated very easily. What about this? Here one of the ways, you can take either only x square equals to t substitution or entire equals to t. So I'm putting, for example, x square minus 1 equals to t substitution. So differentiation gives us 2x equals to dt by dx. So here into dx. So therefore x dx will be half dt. So this question will be reduced to half. This x dx gives us dt here, and this is root t. Minus, what about this? This is, if you remember, log of mod of x plus the same expression. Which formula you have used? This one, just for your information. You have used this root of x square minus a square, which is log of mod of x plus the same expression. Here a is 1, remember. You have used this. Okay. How do we integrate this? That you know, take that root into the numerator, t raised to minus 1 by 2 dt. This one as it is here. What is integral of t raised to minus 1 by 2? Raise the power by 1. Minus 1 by 2 plus 1. 1 by 2 upon 1 by 2 minus log of mod of x plus the same expression plus c. So this will get cancelled. You are left with just root t. But what was t? That is x square minus 1 minus log of mod of x plus the same expression. So this is your required integral. Now let's go to question number 8. The 8th question, that's again known to you. You can see that there in numerator you have x square, in the denominator you have x raised to 6 plus a raised to 6 dx. A raised to 6 is not important because this is a constant. But you know that here x square is derivative of x cube. So what you need to do? Just put x cube equals to t. So this will be in dt. So 3x squared dx equals to dt. Now you must have realized in earlier questions also you have used this. Question number 1, if you remember, you had x raised to 6. You see the first question. So you have placed x cube equals to t. Same thing here. And now you just continue. X squared dx become 1 by 3 dt. So this will be 1 upon 3 here. 1 upon 3. This is dt here. And what about this? Raised to 6 means t squared. And a raised to 6 as it is. Now this is which formula? The same formula. Variable first. 1 upon 3 log of mod of x. X means t. Plus the same expression. Root of t square plus a raised to 6 plus c. Which formula? Log of mod of x plus the same expression here. So t plus the same expression, and finally place the value of t. 1 upon 3 log as it is. What is t? That is x cube. Plus here this is x raised to 6 plus a raised to 6 plus c. Required integral here. Nth question. Integral of sec square upon root of 10 square plus 4. So obviously sec square is derivative of 10. So we just put 10x equals to t. Only 10x equals to t, remember. Why this? Because if you differentiate this, sec square x dx equals to dt. So this become dt here. So this is equals to here dt. I'll keep an aside. Upon here t square plus 4. 4 you can write 2 square if you want. Now this is a standard formula. So you know answer here. Log of mod of x. X means t. Plus the same expression, that is t square plus 4 plus c. So this is log of mod of what is t, which is 10x, plus root of 10 square x plus 4 plus c. Which formula I've used? Just I'll show you here. This one, root of x square plus a square. And what's the integral of this one? Log of mod of x plus the same expression plus c. This formula you have used here. Formula should be there in your mind, remember. Okay, the next question now. Question number 10 here, 10th question. You have 1 upon root of x squared plus 2x plus 2. You must have realized this is 1 upon quadratic form. Integral of 1 upon quadratic. and every quadratic you can express as here sum or the difference of the two perfect squares. Okay, so over here this is 1 upon root of, what we do is here, x square plus 2x we are not going to touch. What will be the last term? Coefficient of middle term, which is 2. So last term equals to coefficient of middle term 2 upon 2 the whole square, so which would be just 1. So last term would be 1. Plus 2 is there, so I'll write just plus 1. In short, what you did, you just rearrange to make this one as a perfect square. Now this is nothing but root of, what is this? This is x plus 1 the whole square, plus 1 is 1 square. I hope this is clear to you. 2 I have just rearranged plus 1 plus 1. Why I wrote plus 1 here? Because as I explained, the last term is coefficient of middle term by 2 whole square. You have used this concept here. Now this is which formula? Same above formula. This is linear function, remember. So you can imagine this as x. This is root of x squared plus a squared. Same, this formula. So what is the answer here? Log of mod of x. X means x plus 1, remember. Plus the same expression. Same expression means what? X plus 1 the whole square plus 1 square. And if you want, you can write log of mod of this x plus 1 as it is. Instead of this, if you just expand, you will get this. So you can write in form of this expression. X squared plus 2x plus 2 plus c. This is your answer. What is the important step here? Express this quadratic as a sum or the difference of the two perfect squares. So this one plus this, and then just formula, remember. Question number 11, 1 upon quadratic. So we'll make it as a sum or the difference of the two perfect squares. Now here by observation, you can see that this 9x squared plus 6x. So you just need 1 here. This would be perfect square. So from 5, now I'll write just plus 4. Right. This is just by observation. Out of 9, 3 is already used here, and middle term 2, so 6x, and plus 1, you need just plus 1. So what is this now? This is nothing but the 3x plus 1 the whole square, this much only, plus 2 square. What I did, I've expressed quadratic, this quadratic as a sum or the difference of the two perfect square. Here is a summation. Now this is linear function. You can imagine this as x squared plus a squared. What is that? Here 1 upon a, 1 upon 2 into tan inverse x by a. X means 3x plus 1, by a means upon 2, upon the coefficient of x. So you can write whole upon 3 plus c. So finally this 3 you can take outside, 1 upon 6 tan inverse 3x plus 1 by 2 plus c. This is your answer. I'm just reminding you which formula you have used here. 1 upon x squared plus a squared, remember. That is given by 1 upon a tan inverse x by a. You have used this, remember. 1 upon a tan inverse x by a plus c. And here you have considered 3x as x. So you need to write upon the coefficient of x, which is 3. And therefore we are getting this. Okay. Now, next question, that is, again you have there inside the square root quadratic expression, question number 12, which is a good example. Integral of 1 upon root of 7 minus 6x minus x squared. Now in such questions, whenever you have inside the square root minus sign, you cannot take minus outside the square root, remember, because it becomes a complex number. So what we do, within the square root, we take minus sign like this. You just see what I'll do. I'll take minus common from this 2 and I'll write over here. So x square plus 6x, just taking minus common over here. Now what should be the last term here? Middle term coefficient, last term equals to middle term coefficient, that is 6, half of it by 2, the whole square, which is 6 by 2, 3 whole square 9. So last term should be 9. Now actually you wrote here plus 9, but you have minus sign in front of it. So you are subtracting 9. So I need to write plus 9 and plus 7 is already there, remember. I hope this is clear to you. You expand this, you will get just this much. What I did, from the term involving variable x, I have taken minus common, x square plus 6x. You need 9 here, so you are subtracting 9. So I need to write plus 9 and plus 7 is already there. So here you are getting root of 9 plus 7, 16. So 4 square minus, what is this? This is nothing but the x plus 3 the whole square. Okay, so now this is inside the square root. You have a square minus x square, constant first. So answer will be in form of sine inverse. Sine inverse x by a. X means x plus 3 by a. By a means 4, remember, plus c upon the coefficient of x, which is 1. So this is required integral. Again, just to remind you which formula I've used, 1 upon a square minus x square, which is given by what? Sine inverse x by a, remember, plus c. You won't be having 1 upon a in front of this. You have used which formula here? 1 upon root of a square minus x square. If you have constant first, your constant first inside the square root, remember. So your answer will be in form of sine inverse. This is your x upon the coefficient of x, which is 1. So we are getting this. So question number 13 here. 1 upon root of x minus 1 into x minus 2. Now this is just quadratic. You open the bracket here. So this is root of x squared minus 3x plus 2. And you know how to do this now. Express quadratic as the sum or the difference of the two perfect squares. Right? So this can be handled very easily. I'll just show you. What would be the last term here? X squared minus 3x. Coefficient of the middle term by 2. What's the coefficient? 3 by 2. So 3 by 2 squared. So 9 by 4. Adding this and subtracting this. Plus 2 is already there. Minus 9 by 4. Fine. Why I did this? Because this is a perfect square. From where I got this? 3 by 2 whole square, which is 9 by 4. Okay, now this is equals to, finally, this is x minus 3 by 2 whole square. This is nothing but 8. So I'll get the here minus 1 by 4. Now this is one known formula. Imagine this is x. So you can do it. I'll go to question number 14 here. In the question number 14, it's like question number 12 only. Question number 14, integral of 1 upon root of 8 plus 3x minus x squared dx. Your minus x squared. You see, in the question number 12 also, you had minus x squared. Here also minus x squared. So inside the square root, if you have minus x squared, the answer would be in form of sine inverse, you will notice. So here, what I did there in the 12th question is the same as question number 12. Both are same. you just take minus common from this 2. This has to be plus. So x squared minus 3x. X squared minus 3x. What should be the last term? Half of this whole square. So plus 9 by 4. What I did, I wrote here plus, but actually because of this minus, this is minus 9 by 4. So I need to write plus 9 by 4, and plus 8 is already there, remember. I hope now this is clear to you. I repeat this. What I did, taking minus common from this 2, x squared, this plus become minus. Now what should be the last term? 3 by 2 whole square, 9 by 4. I wrote here plus, remember, last term is always plus, but outside minus is there. That means you are subtracting 9 by 4. So I need to write plus 9 by 4 plus 8 is there. So you are getting 1 upon, now let's simplify this. 8 fours are 32 plus 9, that's 41. 41 by 4. So I'll write root 41 by 2 the whole square. Minus, what about this? This is x minus 3 by 2 whole square. So what you did so far? This is not integration. This is simple algebra. What you did? You have expressed this quadratic. You have expressed this quadratic as a difference of the two perfect squares. Now integration will come into the power, remember. You have constant first. So answer will be in form of sine inverse. Sine inverse x. X means this, x minus 3 by 2 upon root 41 by 2 plus c. So this is equals to sine inverse, this is 2x minus 3, 2 will get cancelled, upon root 41 plus c. Which formula I have used? Constant first, then the formula will be in form of sine inverse, as you did in question number 12. See here, constant first, sine inverse x by a. So here sine inverse x means this expression, x by a, upon the coefficient of x, which is 1 here, so no need to write, and then just simplifying this, 2x minus 3 upon root 41. So this is the required value of integral in question number 14. Now question number 16 to 23, all are based on linear upon quadratic, remember, based are on linear upon quadratic. So every way we do those two steps. First we set the derivative and then we'll split into two integrals. So let me go to question number 16 here. Integral of 4x plus 1 upon, inside the square root you have 2x square plus x minus 3, linear upon quadratic. So what is the first step? Set the derivative. What's the derivative of this denominator expression? 2x square plus x minus 3. So here derivative is 4x plus 1. 4x plus 1, which is already set there, nothing you have to do. So what we do, we take just this one equals to t, because it is already there, remember. If it is not there, we need to set it. So we put this equals to t. So 4x plus 1 equals to derivative of t with respect to x, dt by dx. Dx I'll take on left hand side. So this become dt. So here this is dt and this is root t. How do we integrate this? Take root into the numerator. If I take root into the numerator, it is t raised to minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c. So this is half, this is also half. This is 1 by 2. So it will be 2 in turn. And this is again 1 by 2. So root t plus c. And what is t finally? T is here 2x square plus x minus 3 plus c. This is your answer. Your question is little bit easier because you could set derivative. In fact, derivative were given directly. This were given in the numerator. If it is not there, you need to set it. Question number 17. As I told you, linear upon quadratic. Now what's the derivative of this quadratic? D by dx of just that quadratic expression. X square minus 1 is 2x. You have x. So what I'll do? I'll just multiply and divide by 2 to get the 2x. So 1 by 2, here 2x plus 4. So you got the derivative now, and then we split into two integrals. Why I'm multiplying dividing by 2? Because I need 2x here. Now you split into two integrals. So if I split into two integrals, 2x upon root of x square minus 1 dx plus this 4 is already there, half is applied to both. 4 upon root of x square minus 1. This is, you can see 1 upon quadratic form. This is, how do you handle? Just put x square minus 1 as I did in the previous question. Put this equals to t. Put x square minus 1 equals to t. So what's the differentiation? 2x dx equals to dt. So this become dt. So here, like previous question, half. This is nothing but in the denominator root 2. So minus this t plus, you can integrate this very easily. Here you are left with 2. And what is this 1 upon this? It's a standard formula, log of mod of x plus the same expression, which is x square minus 1 plus c. Okay, and how do you integrate this? You raise the power by 1. If you raise the power by 1 here, minus 1 by 2 plus 1. So 1 by 2 upon 1 by 2 plus 2 times log of mod of x plus the same expression here plus c. So this will goes away. You are getting root t, but t was x square minus 1 plus 2 times log of mod of x plus the same expression plus c. This is your required integral. Here we have just set the derivative. This is the required derivative, and once you get the derivative, you split into two integral. One is this, second one is this. And here you took the substitution like the previous question. This is the standard formula, x square minus a square, log of mod of x plus the same expression, remember. Okay. Next question is again linear upon quadratic. So what is the derivative of this one? 6x plus 2. Here you have 5x minus 2. So what I'll do, I'll use the technique. This equals to 5x minus 2 equals to some constant into derivative of this expression, which is 6x plus 2 plus some another constant. What I want to do, instead of the numerator, I want to set derivative plus some constant. So 5x minus 2 as it is. Here, if I open the bracket, 6ax plus this is 2 into a, 2a plus b. Now what we do? We compare the coefficients and constant term. What is the coefficient of x here? 6a. What's the coefficient of x here? 5. So you got a from this. What is a from this? A is 5 by 6. Now constant term, 2a plus b equals to minus 2, not 2, remember. Minus 2 equals to 2a plus b. A you are having, so you can get the b here. So minus 2 minus 2a, 2 into 5 by 6. So what is b from this? Minus 12 minus 10. So minus 22 by 6, which is minus 11 by 3. This is b. Okay. Now we place there here a and b. So the above integral would be, I'll write I means above integral. I equals to integral of a What is a? 5 by 6 into this much, which is 6x plus 2, plus b, which is minus 11 by 3, upon, I'll just copy this expression, 3x square plus 2x plus 1. What you did? You have set the derivative of denominator expression into numerator, remember. I repeat, what you did, you have set the derivative of this expression over here by this technique, remember. If I simplify this, you can simplify, you will get exactly 5x minus 2. So this is not integration, this is just algebra procedure, remember. See, I'm simplifying here in a rough just to show you. For your information, I'll open the bracket, 6 will goes away. So this is 5x plus what is this? 5 to the 10 by 6 minus 11 by 6, 11 by 3, that is 22 by 6. What is this? 5x, this is nothing but minus 12 by 6. So 5x minus 2. Understood? This is just for your information. I'm just trying to tell you that instead of this, you set this through this procedure, finding a and b. What I did here, numerator expression equals to constant into derivative of this plus some another constant, and then I've compared the coefficients of x, which is 6a, coefficient of x 5, constant term 2a plus b, constant term here minus 2, and then just getting a and b. This is step number 1. What is the step number 2? Split into two integral. These upon this, 5 by 6 being constant outside, 6x plus 2 as it is here, upon 3x square plus 2x plus 1, minus 11 by 3 being constant, I'll keep it outside. Here 1 upon 3x square plus 2x plus 1. Now both are known integral. This is which form? See, earlier you had a question, but there you had with square root. You see this question. Here this is without square root. In this question you had a square root. So you need to take the substitution because you have square root. But here we don't have square root. So directly it is which form? F dash upon f. You see, this is nothing but f dash. And this is f. So what's your answer to the first term? That is 5 upon 6 log of mode of denominator expression 3x square plus 2x plus 1. F dash upon f, log of mode of denominator expression, minus 11 by 3. How do we handle this? Like earlier questions as you did in the beginning. 1 upon quadratic. Every quadratic can be expressed as the sum or the difference of the two perfect square. This one plus or minus some constant square. That's what we want to do. Okay, so here normally what we do, we make the coefficient of x equals to 3 to make it easier. So I'll take 3 outside. So this 3 and this 3 become 9 here. If I take 3 outside, this is x square. This is 2 by 3x plus 1 by 3. Why I did this? Just to make the coefficient of x squared equals to 1. To make the perfect square, this would be easier. So here, this 5 by 6 log of mode of 3x square plus 2x plus 1 as it is here. Here integration is done, minus 11 by 9. What about this here? X squared plus 2 by 3x. Now we want the last term. How do we get the last term? Coefficient of middle term by 2. So if I do by 2, you are left with 1 by 3 only and square it. So 1 by 9. Plus 1 by 3 is already there. I've added 9, 1 by 9. So I need to write 1 by 9 whole dx. Right? I hope this is now clear to you. Coefficient of middle term is 2 by 3. You do half of this. You will get 1 by 3, square it. 1 by 9. I'm adding 1 by 9. I need to write minus 1 by 9 plus 1 by 3 is already there. Now this much is a perfect square. Okay, so let me do that here. So this expression as it is, I'll copy the first expression, 5 by 6 log of mod of 3x square plus 2x plus 1 as it is, minus 11 by 9 here. What about the first three terms? It is x plus 1 by 3 the whole square, this one. And at this place, here you need to simplify. So take 9 as LCM. So here 3 minus 1, that is 2, 2 by 9. So which I'll write root 2 by 3 the whole square. Please observe it carefully. Please check this. What is that simplification? If I take 9 as LCM here, this is 3 minus 1, which is 2 by 9. So root 2 by 3 the whole square. Okay. Now this is x square plus a square, so it is the tan inverse formula, 5 by 6 log of mod of 3x square plus 2x plus 1 minus 11 by 9. This is x, this is a, x square plus a square. That's the tan inverse formula. So 1 upon a, that is root 2 by 3 into tan inverse of x by a, root 2 by 3 plus c. Which formula? 1 upon a tan inverse x by a. What's the coefficient of x here? 1. So you have to divide a whole by 1. So now final step. I understand this is little bit lengthy but not difficult. So here this 3 will get cancelled with this. So 11 by 3 root 2 tan inverse here 3x plus 1 upon root 2 plus c. So required integral. Okay. Now 18th we are through with it. 19th same question. You just open the denominator. So we'll get the quadratic. I'll go to 20th. Question number 20th. Integral of x plus 2 upon root of 4x minus x square, linear upon quadratic. So we need to set the derivative of this here. What's the derivative of this one? 4x minus x square, which is 4 minus here 2x. Derivative of 4x is 4 and derivative of x square is 2x. So we need to set this one over there. So here no need to use AB because you can just multiply this with minus 2. So I can write x plus 2 multiplying dividing with minus 2. Directly it can be done. So minus 1 by 2 minus 2x minus 4. But I need plus 4. So I'll write one more step here. Minus 2x plus 4. Why plus 4? Because I need this. And I'm adding 4. So I need to write minus 4. But minus 4 is already there. So minus 8. I would just set. Right? This way it can be done if you feel that this is easier. Or by AB method you can do, of course, remember. That's always there. Okay. So now the above integral, let me call that as I. The above integral I reduced to, instead of this, you have minus 1 by 2 into minus 2x plus 4. This and this, minus 1 by 2 plus 8. So it is just plus 4 upon this expression. So what I did, just I've set the derivative of this quadratic over here, remember. Now what is the next step? Split into two integrals. So your next step is here, I'm just splitting into two integrals. So if I split into two integrals here, minus 1 by 2 I'll keep outside, minus 2x plus 4 upon root of 4x minus x squared plus this 4, you can keep it outside, upon 4x minus x square the whole dx. Okay, I hope this is clear to you. How do we do the first integral? You have root, remember, so you need to use the substitution. You put this equals to t, so this become dt. Fine, so we put 4x minus x squared equals to t. So 4 minus 2x equals to dt by dx are right here, so this become dt, you can notice. And this is 1 upon quadratic with minus x squared. So we had earlier such two questions, question number 12 and question number 14. Like that we'll do here. So here minus 1 upon 2, this much is dt and this is t. So if I take in the numerator t raised to minus 1 by 2 dt. This is dt, this is root t in the denominator, I have taken into the numerator, plus 4. What about this? How do we do this? You know, if you have minus x squared, this is same as question number 12 and question number 14, remember. So I'm doing the same technique here. Answer will be here in form of minus x squared is there, so in form of sine inverse, remember. What we did there? Take minus common here from this 2. So x squared minus 4x. What should be the last term? Middle term coefficient by 2 whole square. So 4 by 2, 2 whole square plus 4. Last term is always plus, remember. If I do plus 4, but because of this minus sign, you have minus 4. If I do minus 4, I need to do plus 4, the whole dx. This arrangement should be clear to you. Minus 1 by 2. What's the integral of this? Minus 1 by 2 plus 1. 1 by 2 upon 1 by 2. 4 into, now finally here, this is nothing but 2 squared minus x minus 2 the whole square dx. Okay, so this will get cancelled here. Minus, what was t? T was 4x minus x squared. And root, raised to 1 by 2 means root, plus 4. Now this is a squared minus x squared. This is x because this is linear function. So what's the integral? Sine inverse x by a. A means 2 plus c. So final answer is here minus root of 4x minus x squared plus 4 times sine inverse x minus 2 by 2 plus c. Remember here constant first. If you have constant first, answer will be in form of what? Sine inverse. Sine inverse x by a, remember here. So if I just show you that question number 13 here, see the question number 13, same way. Sorry, question number 14. You can notice sine inverse x by n. This is same as question number 12 here. You can see this question number 12. Sine inverse x by a. Question number 21, linear upon quadratic. So set the derivative. Let's notice the derivative of this. D by dx of x square plus 2x plus 3. What is that? It is 2x plus 2. Now here no need to use that AB method. You can do directly here. This x plus 2 equals to here. I need 2x here. So multiply and dividing by 2. So 2x plus 4 and then 1 by 2 into 2x plus 2 plus 2. And now you split into two integrals here. So I equals to here, instead of x plus 2, I'll write here 1 by 2 into 2x plus 2 plus 1 by 2 and 2. So it becomes just 1 upon root of x square plus 2x plus 3 the whole dx. Now you consider two different integrals. Step number 2, split into two integrals. x square plus 2x plus 3 plus here 1 will go out here, root of x square plus 2x plus 3. Now this won't be difficult for you. You take this equals to t and do as we did earlier. And here this you can write x square plus 2x. Last term is 1. So 3 I can write 1 plus 2. This become perfect square. So that we can do. Question number 22. Again, not that much difficult. Linear upon quadratic. X square minus 2x minus 5. What's the derivative of this quadratic? 2x minus 2. So you can set that very easily because here you have 2x, here you have 2. So x plus 3 multiplying dividing by 2. So you are getting 2x plus 6. I want minus 2. So I'll write 2x minus 2. If I do minus 2, I need to write plus 2, but plus 6 is already there, so it becomes plus 8. Right? So therefore, instead of x plus 3, you have this. So I equals to, inside the integral, 1 by 2 into 2x minus 2, this portion. Take 1 by 2 inside. So plus 4 upon x square minus 2x minus 5 dx. Now what we do? Split into two integrals. You know, this upon this, which is f dash upon f. 4 upon this. Make it somewhat the difference of the two perfect squares. Okay. Next question number here, 23. That's same question. Try yourselves. This is for you. Try it. It's a good question. Do not drop it, remember.